In this video lecture, we will look into those nucleophilic addition reactions of aldehydes and ketones where water would be eliminated. Like we discussed in previous video lecture, that nucleophilic addition reactions would be of two types. In the previous lecture, we have seen those reactions where water was not eliminated, right? There was no water elimination in those reactions, in those nucleophilic addition reactions. Now, in this lecture, we will be looking into those reactions where water would be eliminated and a condensation product will get formed, right? So, it's of this type. We will be going through these reactions where water would be eliminated, right? And water, since we know that water is H2O, so this oxygen will come from this carbonyl oxygen, right? So here in these products, this carbonyl oxygen would be removed, right, in the form of water. And we'll be looking into reaction in this type of reactions. We'll be looking into reactions with ammonia and the derivatives of ammonia. The derivatives of ammonia would be NH2G, right, where G represents, where G can be your OH, NH2, right, NHCO, NH2. This is NH2. When this G is OH, it is hydroxylamine. When your G is NH2, it is hydrazine. When your G is NHCO, NH2, this is semicarbazide, right? So let's quickly look at first the reaction of aldehydes and ketones with ammonia, right? So let's look into the first reaction where aldehyde will react with ammonia. Aldehyde, say your acetaldehyde, right, will react with ammonia right in ethereal solution, right? Ammonia is taken in ethereal solution, right, where it will form an addition product which is CH2H OH NH2, right? So one H will go with this oxygen as OH, NH2 will combine with this. Now this is an unstable compound, right? If this is warmed with water, a water molecule would be eliminated. CH3H. Since a water molecule would be eliminated, H from here, OH from here and H from here, what would be left? Double bond NH, right? This is your aldimine, right? These are your aldimines, right? And here plus water molecule. Water molecule would be eliminated. This is an aldimine, which is, these aldimines are very reactive compounds. They react with one another to form a cyclic trimer, right? They form an addition product, a cyclic trimer, since aldimines are very reactive, right? Now let's look at the reaction with formaldehyde. This is an important reaction with formaldehyde. HCHO will react with ammonia to give you an addition compound. 6 molecules of formaldehyde will react with 4 molecules of ammonia to give you hexamethylene tetramine, this CH2N4, right? This is your hexamethylene tetramine. We also call it as urotropine. Just remember the name. We call it as urotropine, or since it contains 6 methylene group, so we call it as hexamethylene 4 nitrogen tetramine, right? And it has a structure. If you look at its structure, it would be like this, right? Right. Now this will just rub it. then you have this, right? Then you have one nitrogen. This is the structure for hexamethylene tetramine, right? This is your CH2 and this is your CH2. This is a structure for hexamethylene tetramine. Remember, just draw NCH2N, CH2NN. You join all these, right? Then you have this nitrogen will be connected to CH2, this nitrogen will be connected to CH2, and then both these CH2 are connected to nitrogen. Now these two nitrogens are linked via this methylene group. So you have 1, 2, 3, 4, 5, 6 methylene, hexamethylene, and you have 1, 2, 3, 4 nitrogen, tetramine. This is the structure for urotropine, right? Now let's look at the other reaction. These are the reactions of aliphatic aldehydes. But if you react aromatic aldehyde, benzaldehyde with ammonia, it will form a complex compound benzamide, right? It will form hydrobenzamide. Let's look at it. Right? This is the structure for benzaldehyde. Right? 3 molecules of benzaldehyde will react right. Now you have ammonia, 2 molecules of ammonia right. 2 molecules of ammonia will react with 3 molecules of benzaldehyde to form hydrobenzamide. Right? And notice, as I said in the beginning, that carbonyl oxygen in these reactions would be lost as water. Here also it would be lost as water, and here also this carbonyl oxygen would be lost as water. Right? And what product will result? So you have 3 molecules of water that would be eliminated here. Like this. Then we will draw the other molecule. Right? Now you have this, and you have to adjust this nitrogen as well. Right? So here you have this H2 is removed with this oxygen. These 2 hydrogens are removed with this oxygen. Right? So you have carbon, double bond nitrogen. Just learn how to draw the structure. Right? Now both these nitrogens are linked to this remaining molecule. Right? So you have like this. This is your hydrobenzamide. This is a complex compound named as hydrobenzamide. Right? I hope this structure is clear. Right? Just remember how to make this structure urotropine and this. Remember that with benzaldehyde you have 3 molecules of benzaldehyde that will condense with 2 molecules of ammonia to form hydrobenzamide. Right? Now let's look at the reactions with ammonia derivatives. Or let's first look at reaction with ketones. These are reactions with your aldehydes. So just copy these reactions. I'll just remove it. Now we'll look at the reaction with acetone. With acetone, it will form acetone ammonias, right? And two molecules of acetone will react with ammonia, right, to give you diacetone ammonia. Let's first see how the first molecule of acetone will react. Right? So this reaction, it will form complex ketone amines. We call the product would be, in this case, complex ketone amines. Right? And at lower temperature, at higher temperature, two molecules of acetone will react. First, it will form addition product NH2. Now at high temperature, another molecule of CH3 CO, just notice the formation of final product. Here one hydrogen atom and from here OH will react, right, and remaining molecule will add to it, right, because in all these reactions water would be eliminated. So now the product that will get formed would be CH3 NH2, then you have CH2 CO CH3. This is your diacetone ammonia. Right, I hope this is clear. Now we'll be looking into the reactions of ammonia derivative like we have discussed here, NH2G. Right, reactions or with the derivatives of ammonia will take place in acidic medium. Right, so let's first quickly look at the mechanism. Since I said that it takes place in acidic medium, right, here you have plus acidic medium, it will form OH, right, it will form OH bond. Now this is the derivative of ammonia, so just learn this mechanism, this is important. Right, so through this lone pair, on the lone pair which is on nitrogen, it will connect to this positive carbon atom, right, to form this compound. Right, now from this compound hydrogen would be removed, right, from here the hydrogen would be removed or lost, this hydrogen would be lost, right, to form NHG. Right, just notice the formation of this, that is from here hydrogen would be removed to form NHG. Right, now with another hydrogen it will form OH2, right. Now this is a better leaving group, this is water, would be removed as H2O, right? And another hydrogen would be removed from here. So what it will form is Ng, right? This is the final product that you will see in all the reactions with ammonia derivatives, right? Or in simple way, you can write this, just know how, what does this acid catalyst is doing, right? How this is reacting. This is the entire mechanism of this reaction. And in a simple way, you can also write it as, in a simple way, if you want to write it, right? These two hydrogens will combine with this carbonyl oxygen, because we know that water would be, the water that would be lost contains oxygen from carbonyl group, right? Now here you will get Ng, right? So this hydrogen and these two, this oxygen and these two hydrogen will be removed as water, and what you will get is this. Right, now let's quickly look into some reactions. We'll first look into the reaction with hydroxylamine. It will form oximes. With hydroxylamine, it will form oximes. Right? Aldooximes and your acetaldooxime and acetoxime with aldehydes and ketones. Reaction with first with aldehyde. Remember, oxygen will always be from carbonyl oxygen and hydrogen. This is your oxime, right? We will call it as, this is your acetaldehyde, this would be called as your ethanol oxime, since this has come from acetaldehyde. So this is your ethanol oxime, or we call it as acetaldooxime. Acetaldooxime. Right? Similarly, ketones will react to form ketoximes. Right? This is your ketoxime. Or we call it as acetoxime. This is your, since this is from acetaldehyde, we call it as acetaldooxime. This is from acetone, we call it as acetoxime. So basically, aldehydes and ketones will react with hydroxylamine to form oximes. Right? Now let's look at the reaction with hydrazine. With hydrazine, it forms hydrazones. Right? The products would be your hydrazones. With acetaldehyde, it will form acetaldehyde hydrazone. With ketones, it will form acetone hydrazone. Right? Let's quickly look at the reaction. It's a simple reaction. So with hydroxylamine, remember it will give you oxime. You just have to remove a water molecule, and rest of the addition compound is your oxime. Right? Now with it will react with hydrazine. Right? And it will form minus H2O. Right? This is your hydrazone. This compound is your hydrazone. We call it as acetaldehyde hydrazone. Similarly, ketone will react in the same way, similar way. It will react, water molecule would be eliminated. Double bond, same as this, N dot NH2, right, plus H2O, right. So this product is your acetone hydrazone, right. This product is your acetone hydrazone. Now we'll look with the reaction with phenylhydrazine. With hydrazine, it forms hydrazones. With phenylhydrazine, also it will form phenylhydrazones. So phenylhydrazine would be where one hydrogen would be replaced with a phenyl ring. Right. Let's directly look at the reaction. CH3H, double bond O, H2N, NH. Yes. Right, this is your phenylhydrazine. So it will react again, same as above, a water molecule would be eliminated and it will form CH3H, double bond NH. Right. This is your phenylhydrazine. Right. The name of this compound is acetaldehyde. Since this is formed from acetaldehyde, so this compound is your acetaldehyde phenylhydrazone. Now the reaction with ketone, acetone, right, the same way, NH. This is your acetone phenylhydrazine, hydrazone, I'm sorry. Right, now let's look at its reaction with semicarbazide. Right, with semicarbazide it will form semicarbazone. Let me just write it over here. Acetaldehyde will react with semicarbazide. Its the formula is NH2 NH dot CONH2. Right? This is the formula for semicarbazide. Right? From hydrazine, right? This is your hydrazine. From hydrazine, from one hydrogen atom would be replaced with this acetamide, CONH2. What you get is your semicarbazide. Now here again, one molecule of water would be eliminated, right? And what it will form is CH3H, double bond N dot NH, CONH2. Right? This is the product. Similarly, if I take acetone, right? Acetone, it will form acetone semicarbazone. Right? For acetone, we can replace this hydrogen with CH3. Similarly, here we can replace this hydrogen with CH3. It will form this product. Right? This is your acetone semicarbazone. Right? I hope this is clear. Now we have another reaction, which is your reaction with addition of thioalcohols, mercaptans. Right? It will form mercaptols. Firstly, thioalcohols is where you have SH group, not OH. In thioalcohols, you don't have OH. Thio means sulfur, thio compounds are where you have sulfur. So thioalcohols are compounds where you have SH group. Right? Just take this off. Right. So it will form same type of compounds as aldehydes and ketones formed with alcohols. If you remember, with alcohols it formed gem dialkoxy compounds, right? Where you have two alkoxy group OR combined to the same carbon atoms. Something similar would be here. You have CH3H, right? Then you have your formula would be C2H5SH, right? So this is your thioalcohols, which is your SH, right? So when it reacts with SH, it will react with two molecules of SH, like here. Here this one molecule of water would be eliminated, CH3H. Then you have SC2H5, SC2H5. Right? This is your mercaptols. We call these compounds are acetaldehyde mercaptal. Right? Similarly, acetone will react with it to form acetone mercaptol. Right? So I hope this is clear. Similarly, same reaction would be with acetone. If you replace it with hydrogen, you get acetone mercaptol. We call these compounds where you have these mercaptols. Right? This is your, if you have hydrogen here, this is your acetone mercaptol. Right? The other one was when you had H group, that was acetaldehyde mercaptol. Right? I hope this is clear. Now let's look at the last reaction of 2,4-dinitrophenylhydrazine. We know how phenylhydrazine looks like. This is your phenylhydrazine. Now 2,4-dinitro means at 2 and 4 position we have nitro group. Right? So in the same compound you have nitro group. At this position, 2, 3, 4. At this and this position you have nitro group. So that would be 2,4-dinitrophenylhydrazine, and it will form 2,4-dinitrohydrazone with your aldehydes and ketones. Right? So let's just quickly look at that reaction. CH3H. Right here in the same way, H2N H2. Right? Here you have NO2. Here you have NO2. Right? It will form CH3H double bond NH NO2. Here you have NO2. So this is your compound. We call it as, the name of this compound is 2,4-dinitro. This compound is, the nitro group is at 2 and 4 position. So this is your 2,4-dinitrophenylhydrazone. Similarly, acetone will react with it. If I remove this hydrogen with CH3, it will form, the name of this compound would be acetone 2,4-dinitrophenylhydrazone. Right? So in all these reactions, we have noticed that a water molecule was eliminated, right? And a condensation product is formed. Because we know that in condensation reactions only, a simple molecule like HCl or H2O would be eliminated. So all these those compounds that we have studied were condensation products, right? I hope all this is clear. Thanks.